Okay, Algebra 2 should be the 23rd. We're doing Unit 5, lessons 4, 5, and 6, and then later today we're going to have the Castle Learning will open. You got to finish it sometime on Friday. You got till midnight on Friday to finish that Castle Learning. All right, so I started putting some notes here. Arithmetic series and geometric series, and maybe forgot what some of this stuff means. What's n? That's the number of terms we're going to add up. So we're just adding a bunch of numbers. There's the first term, there's the last term, and there's our formula. Over here, geometric series, if we want to add up a whole bunch of geometric numbers, 2, 4, 8, 16, 32, 64. Let's say I kept on going, I wanted to add 20 of these numbers. I wanted to add them up quick, I would use this formula. What do I need? The first term, the ratio, and the number of terms. All right, so this first one, I already started it. Looking for an arithmetic series, so I'm going to be using this formula. The sum, the answer, is 1,675. They're giving me the answer already. They're telling me that the total is 1,675. And here's the first term. There's the last term. How many terms are there? Did I add up 12 numbers, 22 numbers, 50? Well, here's the choices. How many numbers did I add up? So here, where I see SN, I'm going to say, well, there's the total. I don't know what N is, but I know the first term is 7, and the last term is 127. All right. Add that up, I get 134 and divide by 2. So, got that? 7 plus 127, 134, and then half of that, 67. So, add it up, divide by 2, I get 67n equals 1675. Divide by 67. 1675 divided by 67 gives me 25. So n equals 25. Choice 3. So there was 25. I listed them all out. There's 25 numbers. I don't even know what the difference is. I didn't have to find it. All right, now we're moving to geometric sequence. The first term is 2,000. The second term is 500. Like, what are we doing? Now, some of you might say we took away 1,500. That's arithmetic thinking. What did I multiply by? And hopefully you say, well, I don't know. If you're like me, you're saying you divided by 4, but what I really did is I multiplied by 1/4. I multiplied by 1/4. This is 1/4 the size. So the next one, if I wanted the next term, it'd be 500 times 1 divided by 4. There would be the next one. 125 would be the next number, and then so on and so forth. Okay. Add up the first 6 terms. Well, there's the first 3. I mean, it wouldn't take that long to write them all out and add them up, get the answer, but I'm going to do the formula. So I'm looking for S6. Do I know the first term? Yeah, 2,000 minus 2,000. What's the ratio? I'm multiplying by 1/4. Raised to the 6th power. Why? Because I'm adding up 6 terms. This 6 here corresponds to that 6. Down below I got 1 minus the ratio, 1/4. Now be careful, just type that in your calculator, use the fraction feature on your calculator so you're less likely to make mistakes. 2,000 minus 2,000, 1 divided by 4 raised to the 6th power. There's my numerator, divided by 1 minus 1 divided by 4. I don't need parentheses there. So 266 something. 267 right there, choice 2. There's the sum. All right, what's the value of the arithmetic? We're switching again, back to arithmetic series. The first term, common difference. Now, why did they tell me the common difference? Might need that other formula. What's the other one? The one from the last video. Okay. The common difference is 8. The first term is negative 100. They're asking me something about 30 terms. 30 terms. So if I plug 30 in there, what do I get? 29. So what is the 30th term? See, that wasn't given to me. Negative 100 plus 29 times 8 gives me 132. So there's the 30th term. And now I want to add all these up. What is the arithmetic series? If I add all these numbers up, what do I mean? Negative 100, and then the next term, if you add 8 to that, you get negative 92, and add 8 to that, you get negative 80, 4, and you kept on going all the way up to 132. If you added all those up, what would you get? Which one of these? I don't feel like adding them all up. That'd be a lot of adding. So instead, I'm going to use the formula. I'm adding up 30 terms. So again, 30 goes there, 30 goes there. I know the first term is negative 100, and I had to do this work to figure out the last term, 132. So this is 15, and this is 32, whatever 15 times 32 is. 480, choice 4. All right, back to geometric. We got 5, we got 15, we got 45. Again, what are we doing? How are we moving? We're timesing by 3, timesing by 3. There's my ratio, okay? And I pull out my, well, how many terms are there? Now here's one, I don't think it's going to take long. So 45 times 3, 135 is the next term. Multiply that by 3, 405. I don't know if I want to write them all out, but 1, 2, 3, 4, 5, 6, 7, 8, not quite there yet, 9, 10. There it is, 98, 4, 15. There it is. That's the 10th term. That's the 10th term. So what am I doing? I'm trying to add all those numbers up. Add all 10 numbers up. All right, using the formula. A1, I'm going to write the formula out. We know A1 is 5. Minus 5, the ratio, what are we doing? Multiplying by 3, raised to the 10th power, all over 1 minus 3. So again, be careful. Type that in your calculator carefully. So we got 5 minus 5, 3 raised to the 10th power over 1 minus 3. 147,620. Choice 2. Okay. Larry earns $36,000 his first year as a teacher, and he gets a 3% raise every year. Find the total amount of money he would earn over his first 20 years of teaching. So this is a geometric. Why? Because I'm multiplying. What am I multiplying by, though? Be careful. 1.03. You know, here's his first year salary. What do you make the second year? 36,000 times 1.03. You got $37,880. All right, then you can find the next one, then the next one. Write them all out. That's be painful. I'm not doing that. I'm going to use the formula. S20. I'm using this formula because it's a geometric sequence. First term, 36,000. What are we multiplying by? 1.03. He's getting a 3% raise for 20 years over 1 minus 1.03. And this will give me his total salary for 20 years. I always tell students they should guess. I bet he makes over $1 million, right? We'll see. All right, let's see what he makes. Not quite $1 million, almost, maybe one more year. 96,700. $333.48. Round to the nearest cent. There it is. Almost $1 million for 20 years. Okay. All right. At the high school auditorium, the seats are set up. The first row has 14 seats. There's the first row, 14 seats. The next row has 2 more, 16 seats. The next row after that, 18 seats. You see how this is arithmetic? I'm adding 2. There's 27 rows. There's the first row. There's the second row. There's the third row. How many are in the 27th row? I don't know. I guess you could write them all out. Or maybe there's a fast way. Remember, there's a fast way to get down here. So if you're in the first row and you want to move back 27 rows, how many places is that? 26 places. And what are we doing each time we move back? Adding 2. So you multiply that by 2. That's 52. So if this has 14. This would have 14 plus 52. I'm using this formula. Common difference is 2. The first term is 14. I can put it in here if you like. To get from here to here, I got to put 26 in times 2. So 52 plus 14 gives me 66. So this has 66 seats in it. Okay, why do I need that? Because I need to come up with the sum of these 27. And I know the first row has 14 seats, and I had to figure out that the last row has 66 seats. And now I can figure out how many seats are in this auditorium. So 27 divided by 2. You could hit enter if you want. And then multiply that by parentheses 14 plus 66. 1,080. So this comes out to be 1,080 seats. That's how many seats are in the auditorium. All right. This is a good example. Mortgages, real life example of a geometric sequence, but instead of using we're not going to use this formula or this formula, we need a little more complicated formula, but we'll give it to you. There it is. It's all defined for you. It's been a while, but this is the principal, the starting amount, the rate, the number of times you got to pay the mortgage. It's in months, monthly payments, and that's about it. So the Strange family wants to borrow $234,000. There's their principal. The interest rate is 3.25%. Now be careful. That's 0.0325. Okay. They want to take out a 20-year loan. How many months is that? 20 times 12. That's 240 months. They have to pay that, make that mortgage payment for 240 months. Put all that into the formula. So it's a lot of numbers, but it would look like this. The rate divided by 12. 1 plus the rate divided by 12 raised to the 240th power, okay? And then down below, 1 plus the rate raised to the 240th power minus 1. Now that's a lot to type in, so I took the liberty of putting it in already. All right, so I typed it all in. Okay, take my word for it. I put it all into the calculator. It was a lot of typing, and I knew I didn't want to sit here and waste time doing that. So there's my total, just a big calculation. So the monthly payment for this mortgage would be $1,260.20 every month for 20 years. Every month for 20 years to pay for this house. Okay. All right. The Sad family would like to borrow $280,000 to purchase a home. They're going to get 4.2% interest rate, which is pretty high. Algebraically determine the number of whole months the Happy family, the Sad family, would need to include in the mortgage agreement to have a monthly payment of $1,300. All right, so this is much tougher because now they're giving me the answer. I got the principal. What am I missing? I got the rate, 0.042 divided by 12. 1 plus 0.042 divided by 12. See, I don't know what this is though. How many months? How many months? I don't know. We got to figure that out. 1 plus 0.042 over 12 minus 1. And again, we don't know what n is. So this is a tough question. Make it a lot less tough by doing this first. 0.042 divided by 12. 0.035. So right here, and right here, I'm going to change all those. 0.035. 1.0035. 1.0035. These are both raised to the n minus 1. So it's been a while since we've done this. I would multiply these together. They're just normal numbers. So what is that? 2,800. 280,000 times 0.0035 gives me 980. There's my numerator. Still bad. No, I cannot cancel those. What I could do though is cross multiply. Now when you cross this way, don't forget to distribute. So it's 1300, 1.0035, and minus 1300 equals 980, 1.0035 n. Okay, a lot of algebra going on here. Next, this term and this are alike. I'm going to move them together. I want to get the n's together, so I'm going to subtract 1300, 1.0035 n from both sides. So I get negative 1300 equals negative 320, 1.0035. Those are like terms. It's like 980x, take away 1300x, you would get negative 320x. So this stays here. Then I'm going to divide by negative 320. I've been hopeful this will come out nice. Let's see. Yeah, that's maybe a fraction. 65/16. So I got 65/16 is equal to 1.0035 raised to the n. I'm almost there now. How do I get n? How do I solve for n? We pull out our friend, the log. That's how we solve exponential problems. And the n goes in front. So I got the log of whatever this 65/16 is equal to n log 1.0035. Finally, I can divide by the log of 1.0035 from both sides. Put that in my calculator. Put what? Log 65 over 16. Close that. Divided by the log 1.0035, and I hope I didn't make any mistakes. I'm going to get 401.2, or just say, I think it says the nearest month. That's how many months it would take. So let me think about that. 401 divided by 12, about 33, almost 33 and a half years to pay off this mortgage, if you're going to pay $1,300. So a long time to pay the mortgage off. That's why they're the sad family. They're sad about that. Okay, so you got to do similar questions. There's the formulas for multiple choice, and then I made the questions very similar that follow this video, so you can follow my work and you should have no trouble doing this. All right, stay safe.